Hello, everyone. My name is Joanna Turowska, and I'm QA Automation Engineer in ASISoft. And today I'm going to talk about performance testing. Have you heard what happened last year during the pre-sale of the tickets for Taylor Swift concert? If you don't, the website selling the tickets crashed, and there were many unhappy fans, and there was a big lawsuit for the company selling those tickets. And this situation could have been avoided. How? By doing performance testing. Now, let me show you how to do them. Let's go to the plan of my presentation. I will start by a short introduction to performance tests to answer the questions, what are they, what are the types of performance testing, and why we have to do performance testing. Then I will make an overview of performance testing process, what should be done step by step to have good quality performance tests. Then I will talk a little bit about the challenges and what I consider good practices in performance testing. After that, we will make an overview of a few existing tools for performance testing. And finally, I will talk about Bolt, which is a tool developed by ASISoft for performance testing. Let's begin. Performance testing is a kind of non-functional testing that aims to check the behavior of an application by applying on it some load. When we talk about performance tests, we often talk about such factors as response time, load, and stability. What does it mean? Response time is time taken by the server to respond to users' requests. By load, we mean the number of users using the application simultaneously or sending the request to the server at the same time. And stability can be understood as the number of users using the application simultaneously for a certain longer time. There are many types of performance testing. And here on the diagram, I presented the most common ones. The first one is load testing. Load testing helps us understand the behavior of the application when we apply on it expected workload. So if we expect the maximum number of users to be 5,000, we apply this particular load. We run tests for 5,000 users. The next one is stress testing. Stress testing helps us understand the top limits of our application. We execute stress testing by applying a load much higher than expected. The third type of testing is endurance testing. The aim of endurance testing is to verify if our system is able to support the expected load for a longer time. The fourth type is spike testing. The aim of spike testing is to check how our application will behave when we have a suddenly increasing number of users, so at peak traffic events. And the last one is volume testing. Volume testing verifies the behavior of the system while feeding it with high volume data. And of course, which type of tests to perform depends on what we want to achieve on our needs. Now, the main question is why to do performance tests? Well, first of all, to ensure expected level of service and the positive user feedback. None of us likes to wait for a page to load. When we have to wait for a page to load more than a couple of seconds, or we see that the page crashes or shows some errors, we are very likely to leave it. So to avoid losing the users, or in case of businesses, that could be potential customers, we have to have a stable product with a good response time. And to do that, we need to think of making performance testing, possibly before even going to production. The earlier we do the testing, the better. We can identify the issues and apply some improvements at the early stage. And like this, we can have a stable product and scalable product, so that if we think that the number of users in the future might increase, we are ready to scale up our infrastructure. Why else should we run performance testing? Well, to ensure that our application is ready for some high peak traffic events. So the events when the number of users grows suddenly, something that probably wasn't considered during the pre-sale of Taylor Swift tickets. And finally, why we should do performance testing? To cut costs. Here, let me give you an example. We were asked by one of our customers why their infrastructure is so costly. They had a couple of products, they were internal tools, so they didn't have that many users. So in fact, the cost of that infrastructure seemed a little excessive. So they asked us if there's anything that can be done to make the cost smaller. And what we did, we prepared performance tests, we executed them, and thanks to those tests, we were able to scale down the infrastructure in a way that the costs for the customer diminished by thousands of dollars monthly. That was quite successful. The customer, of course, was very happy, and I hope that is a good argument to do performance tests. Now let's go through the process of performance testing. What should be done step by step? The first thing to do is to identify test environment. We need to know what we want to test and where we want to test it. We, of course, want to have a test environment that is as close as possible to the production, or the same as production environment. So we should really analyze the infrastructure, all the specifications and configuration of our infrastructure to ensure that our test environment is consistent with the production environments. In fact, if we don't ensure that, our tests will not be really reliable and won't make much sense. At this point, we should also think of choosing a tool for testing, which would be the best for our needs and for our tech stack. The next step of performance testing is defining performance criteria. This step includes understanding the expected workload, so expected number of users that will be using our application, and set goals and constraints for such performance measures as response time, throughput, latencies, resource usage, and reliability. After that, we should plan and design our tests. Here, it's important to understand well what kinds of users we have, what are the most common flows, how the users behave, which actions they do more often, and which features are most used. And except that, we should also think of what kind of data we want to use for tests and what we actually want to achieve doing those tests, what information we want to gather during tests. The next step is a preparation of a test environment, installation and setup of the tools needed for implementing and testing. Once we do that, we can go to the implementation of tests. So we create our test based on the previously prepared plan. And then, of course, we execute those tests on the chosen tool. And the last step, and probably the most important one, is the analysis of the results. At this point, we can see if our previously defined criteria were met, if there are any improvements to be done to make our application better. So here is when we test, when we apply improvements to the code, to the infrastructure, and after that we can retest and see if there was an improvement in the results. What is also important, what is a nice thing to do, actually recommended thing to do, is to run those tests a few times for the same setup to make sure that our results are actually reliable. Now, it all seems in theory very easy and simple, but in practice, of course, we encounter some challenges in preparing performance tests. The first one, the most important thing to consider when we prepare performance tests is that they should express the reality, reflect the reality as much as possible. So first of all, we want the environment that is as close to the production environment as possible. Secondly, that we have well set the conditions and criteria for testing. Values such as expected workload, so how many users will be using our application, what is the behavior of the users, what are the most used features, endpoints, what are the most common flows of the users. We should also see if there are any kind of events that can cause the traffic on our application to increase. And all this kind of information should be discussed, should be gathered in collaborating with the product part of the business part of the product. So the client or business analysts, they are the ones that should know the product the best and should be able to answer all those questions. Except that when we have a product that is already in production, we can use another solution. We can use analytical tools that help us monitor the traffic on our website. We know exactly how many users entered our website and what they were doing during their session, what were the most commonly used functionalities. That can be really helpful to make the analysis and create the tests that really reflect the reality. So once we gather all those information, of course, we need to implement that. So another challenge here will be to find the right tool for us to be able to put all those constraints, conditions into tests. And now I would like to give you an example that proving how important it is to prepare good tests, really reflecting the reality. Now, there was a company, they had a product that had 3 main tasks to do. The first one was to take a photo every couple of seconds. The second one was to upload that photo. And the third one was some kind of AI-based image analysis. The product was supposed to be a commercial product. They expected quite a high number of users. So they thought that they should do performance testing. That's the right thing to do. And in fact, they prepared them. However, when the product finally went to production, it turned out that it wasn't stable at all. It wasn't efficient, and they were wondering what went wrong. And we had this performance test done, but it's not working as expected. So they asked us to analyze those tests and see if there's anything to improve, to see what went wrong. And in fact, we found a couple of errors in those tests. Let me tell you what were the errors. The first one was the assumption that the total number of users equals the number of simultaneous users. So the number of requests run simultaneously. That's a completely wrong assumption. So thinking that they were running tests for, say, some thousands users simultaneously, they were in reality just running for a few. And then when it was already in production and the number of users was much, much higher, in fact, it didn't work. It simply didn't work. The second error that they committed was testing only one step of the flow. They only consider the step of uploading the photo. And that's a really bad assumption. That's a really bad practice to run tests just for some random steps, random requests. It is really important to consider the whole flow. And let me tell you why. Because they were using that endpoint to upload the photo. It was returning the success, so it seemed that everything was going well. However, what was actually happening, the photo uploaded was going to the queue. That was a huge, huge queue of photos to be processed. So in reality, it really wasn't doing what it was supposed to. It was just adding the photo to the queue. And to give you an idea, if we had this tool working for, say, 8 hours, we would need 20 more hours to free up the queue, to finish processing all the photos that were in the queue. So that was the wrong assumption. There's one more issue with the tests. It was using the same photo for testing, which means they were using all the time the same photo. They were uploading the same photo. And that was wrong because the AI part of the image analysis learned how to process this photo faster, given that it was all the time the same photo, than if it were many different photos. So at this step, I want to mention that it's really important that we have various data, that we have not only just one user with same kinds of data, but we have many different users with with different data, some randomly generated, because then we can encounter, if we have the same data constantly, we can encounter a problem of caching, and the data will be processed much faster, and the results will not be really reliable and will not express the reality. Based on that story, I would like to come to the conclusion that better not to have tested all than having bad tests. Because bad tests can do more harm, because we have this false comfort that everything is going to be okay, that our product is stable, but in reality it can end up in a big failure. And to prove that, I want to tell you another story, another example. There was another company. They had a product that was in normal conditions, in the normal usage was stable and everything was going okay. But they were planning a kind of event that would cause the number of users to grow very, very much. So they needed to be ready for that event, and they decided to prepare performance tests for that. However, and what happened, they prepared those tests, they ran those tests, and they were very successful. They ran perfectly, or green. Response time was great. So they said, yeah, we are ready. And then the event day came, and in fact, it was a big failure. the system didn't sustain the traffic, and some people were called at night to fix that. In general, unpleasant situation. So then the question was, they were tests and they were successful. So why did we end up with this situation? What went wrong? So we checked those tests, and what we found out is the following. This product was, the communication of the product was based on GraphQL requests. I don't know if you have experience with GraphQL. Don't know. Okay, so let me tell you just a little. So let me tell you what the problem was. Basically, in GraphQL, by default, the response code is always 200, almost always 200. In case of some 500 errors. But for most of the errors, basic ones, we get 200 response. So here I gathered a couple of requests with responses to show you what I mean. As you can see, the first one is a successful request. It returns some data, and the response is 200. The second one here is unauthorized error, and yet it returns 200. So we think it's success. But if we check the error inside, we can see that the actual status code is 401, and the error is unauthorized. Another example here is forbidden access error. And again, it returns 200. We have to check the message inside to be able to see that, in fact, it's the error message is 400 free and the error is forbidden access. So by this introduction, I guess you can guess what happened. The tests didn't really consider the fact that all the responses were 200. And what we checked, that in reality, they were all responding with 400 free forbidden access. So they were very, very fast, yet they were completely wrong. It's like in the joke where when a recruiter asks the candidate, so what are your special skills? And the candidate says, I can do calculations very fast. Okay, then, so what is 57 times 99? 120. That's completely wrong. That's not even close. Yeah, but that was very fast. So that's an analogical situation. we had very good results, but after they were completely wrong. So that's a tip for all of those of you who will test GraphQL. Keep that in mind. Keep that in mind that you have to always handle the response properly. And that's another example to show that better not to have tests at all than having bad tests, because it can end up in a failure and you don't even expect it. Now, coming back to the challenges, there are a few more that I didn't mention before, or maybe I mentioned just partially. So the first one is choosing the tool. It can be a little challenging. We need to find the right tool to address our needs and our tech stack. And it would be really good to have a tool that could have the option of monitoring our services during executions. What else is challenging when it comes to performance tests? Well, the problem that there is often no budget to do tests. I know for a fact, I know from experience that clients often don't want to spend too much money on quality assurance and especially performance tests. But I hope after everything I said, after the examples I gave you, that you have enough arguments to convince your companies, your clients, that it is really worth to do performance testing. Now, let's make a short overview of some of the existing tools for performance testing. There are many more than those, but I brought those up because they were kind of tools that we verified before choosing the right one for our needs. The first one is JMeter. It's probably the most popular one. It is open source. It is 100% Java-based. The good thing about JMeter is that it has, as I said, it's very popular, so it has a big community. You can find a lot of tutorials, a lot of documentation on JMeter, so you can easily start writing tests. About what is good about JMeter as well is that it allows distributed load testing in the open source version. What else? It has a desktop application with a nice GUI. It allows people who don't even know programming to write tests. So that's kind of a plus because the entry level is a bit lower, but everyone can write tests. But on the other hand, there is a little problem with tests that are not written in pure code, that they are less, there's less possibility to customize them. The next tool that I want to talk about is Gatling. Gatling was first developed for Scala developers, and now it has the possibility to write tests in Java and Kotlin. Gatling has an open source version and enterprise version. In the open source version, of course, we can run tests. We have a web recorder that helps us record tests. And we have some reporting options. We can create reports with nice, colorful graphs. However, it is a little limited. For example, Gatling has cluster mode, which is only available in Enterprise Edition. It allows us to simulate the traffic from different locations. Another missing thing is that we are not able to check the results of tests real life. We have to wait for the test to finish till the report is generated. The next tool is K6. It's a Grafana tool. It also has an open source version and a premium version. Again, the open source version is a little bit limited. We cannot have distributed testing in the open source version. About K6, you write tests in JavaScript. However, they are run in Go, as JavaScript is a kind of single-threaded language. So we analyzed those tools, and they had their advantages and disadvantages. Maybe the biggest disadvantage for us about JMeter was that the tests were not written in code, so there was less possibility of customization. About Gatling and K6, they had a limited option in the open source version, and the pricing in the premium version was a little complicated. It would be quite complicated to estimate the costs. But luckily, after all this research, we found also another tool called Locus. It's an open source tool, cross-platform. It is Python-based with high scalability due to event-based implementation. It has distributed testing possible in open source. It is very easy to customize. The tests are quite easy to write in Python language. So we really liked it, and we decided to go on with it. Now, the problem was where to run those tests. There are several platforms that allowed running tests in the cloud, simulating many virtual users, like Blazemeter. However, many of them don't allow to run tests on your own infrastructure. So there is a bit of a security issue because our application is exposed outside. That was a kind of a blocker for us. We wanted to have a scalable solution in the cloud that we would be able to set up on our own cluster. So we started thinking about our own tool. There were some other factors that maybe brought us to that. We wanted to be able to gather some more information than the existing tools. We wanted to be able to run tests directly from a repository. Plus some other limitations that led us to, in the end, create our own tool called Bolt. Bolt is an open source performance test platform. If you want to take a while to take a photo or scan the QR code, here's the time. Okay, I guess that's it, I guess. Now, anyway, I can come back to that if you want after. Now, what can be done in Bolt? What it allows us to do? The first thing that you can do in Bolt is you can add your own repositories with tests. It is a very convenient feature. When we run tests, Bolt will directly pull the newest version of test from repository. The second thing that we can do in Bolt is adding various test scenarios. We can add many different scenarios that can have different parameters of total duration, of the total number of users, of the spawn rate, so the number of users spawned per second, different hosts, so different base URL allowing us to run tests on different environments, different numbers of users per worker, and what is also a very nice feature, it allows us to run from different branches on our repository. So when we make some changes on a branch, we can run tests directly from the branch without the necessity of pushing the changes to the master. Except that, of course, we can, once we prepare all those scenarios, we are able to run tests, we can display results with some nice graphs, and we can compare the test results between each other, and we can generate reports. And probably some other stuff that maybe I didn't mention, but you have a question? Uh-huh. This, in fact, I don't want to spoil too much because we will be talking about that after, and there will be the whole presentation after about that. So keep that question. Now I want to talk a little about how to write tests for Bolt. So as I mentioned before, we use a Locust framework. So we write tests in Python, which is the best. If you are interested in how to write tests, you can check the official page of Locust displayed on this slide. It's easily, you can easily find it when you search it in Google. However, if you put just Locust, you will have an insect. The only requirement for tests, for the test file, is that it has to be located in our repository under tests folder. What is also worth mentioning that our test scripts can use all the external packages that we need. They just need to be added to requirements txt file, and they will be automatically installed during tests, and of course all the packages installed by the users. Now I wanted to show you a couple of examples of tests written in Locust framework. As you can see, they are, I think they look quite easy, quite user-friendly. Here the examples are from tests of REST API. However, you can do almost all kinds of testing. We did in the past tests of requests to the database, WebSockets, GraphQL, gRPC, so sky's the limit. However, here we have a simple REST request. What you should do first when you write tests, you have to define classes, user classes. You can see them here. The user classes mean or actual users, so we can have a class for admin, we can have a class for a basic user, or they can mean some kind of scenarios. So here, for example, we have, say, some application for online shopping. And we have two classes. We have user management actions and we have basket actions. Those classes have different parameters. The first one is weight. Weight indicates how often will the given user be spawned. So we can see that the basket actions users will be spawned 4 times more often than user management actions user. The next parameter is tasks. Here we define what tasks can a given user do. And the last parameter is wait time. Wait time indicates how long will a spawn user wait between each task. Here I want to mention, on a side note, that the values are in seconds. Because the first time I ran tests, I was sure that they were in milliseconds, and I was wondering, hey, why nothing is happening? So when we have defined those users, we have to define task sets. So the sets of tasks that a given user can do. So the first one here is user management flow. And as you can see, there are all kinds of tasks related to the users. We have getting a list of user, adding a new user, and getting specific user. And as you can see, that each task has a value assigned to it. This value is a weight. So it also means that this task will be executed at a given frequency. So for example, get users will be executed 3 times more than adding a user. It's a really nice option because it can help us create the real flows, create the tests that actually reflect the behavior of the users. The next task set is called sequential task set. Sequential task set, as the name indicates, means that the actions are done in order sequentially. So in case of this class basket flow, we will first add product to the basket, we will go to the checkout, and then we will go to payment. This is the sequential task set is also a very good option, very good feature, because as I mentioned before, it is really important that we create the whole flows and not just like some single actions. So this kind of class can help us create them. Now let me show you a little bit how Bolt looks like, what we can see in Bolt, what are test results like in Bolt, and I prepared a few shots for you. The first one is the list of test runs. When we go to Bolt, we can choose from the list in the scenario that we are interested in. Then we get this view. On this view, we can see, when we open the button to extend scenario details, we can see what is all the scenario about. And below, we can see all the latest runs. We can see where was the run, the date of the run. We can see what is the status of the run. So as we can see here, we have 3 finished runs and 1 in progress. We can see if they were terminated or something else. We can see some values as response times, how many tests passed, how many failed, what is the total number of requests. And when we click on the button results, we can see some more detailed views about the run. And here is how the dashboard looks like. As you can see, it has a lot of information, a lot of graphs that can be interesting for us for the analysis of the test run. First of all, on the left, we can see that we have the number of requests per second. In the middle, we have the average response time. And on the right, we can see that we have the number of user response. When we hover over those results, we can check the exact numbers at a given point of time. So as you can see here, we can see that at 14, 44, and 47 seconds, we had 1,843 requests per second. At the same moment, the average response time was 6 seconds. And the number of user response was 20,000. Below that, we have some more information divided per request. Let me show you that closer. As you can see here, we have a whole list of endpoints that were tested. And we have all the detailed information per request. So we saw how many times was this endpoint hit, what was the success and fail rate. We see the response times, what was the minimum response, the average and the maximum response, and how many requests per second were executed. Now we can go even further into the details by clicking the details button. And this is how it looks further. We see some more graphs, such as request distribution, response times, total response length, and here is time distribution. So we can see, for example, that 100% of the requests was executed below 6 seconds, and 50% of the requests was executed below 4 seconds. This can be a nice thing nice information to analyze the results. And again, if we hover over those results, we can see some exact number at a given point of time. Now we can go even more to more detailed results. For example, if we click on this loop, it will take us to this view. Here we can see even more details about what was happening. So we can see at the given point how many requests were run and how many of them were successful, and not only how many failed, but also we have the information about the exact error that happened. So we have a very, very detailed info about what went wrong. Now, something that can be very useful as well is that we have the results in both real life. So when the tests are running, we can see the graphs are already showing us what is really happening. We can also check the logs. And finally, what can be done in Bolt, the feature that we do use, is the possibility of comparing test results. We might want to compare the current tests with something that happened in the past and see if there were any improvements done meanwhile. So we can choose a run. We can choose a run to compare it with. So we can select a test scenario. We can select a date, and we can compare results this way. They are displayed side by side. And again, if you hover, you have all the details about the exact numbers. And that's all from me today. To sum up, I want to say a few things. The first one, it is really worth to do performance testing, and I really hope all the arguments I gave you were enough to prove you that. And if you do, you should really plan them well. You should really think them through, because bad tests can do more harm than actual good. And I don't know, I encourage you to try both and let us know what you think about it. Thank you very much.